Hi guys and welcome. In this video I'm going to discuss how I accurately modeled a Tesla Model Y refresh version in SolidWorks using complex advanced surfacing. If you feel like this is something you would like to follow along with to improve your surfacing skills, you can access my files at my website for a small fee. Link in the description below. All proceeds greatly support me and help fund future projects like these. Thank you for your support. Okay, jumping straight into it. So this model is a very large model. It has about 660 individual features, and I've grouped them all up into folders. But there's too much to go through each feature one by one. This video assumes you have some knowledge with complex surfacing. It's not a beginner video. Hopefully it's still interesting if you are a beginner. But yeah, a few important things to go off right away. At the moment, I have perspective turned on. Generally, you don't have perspective turned on when you're modeling, but it is nice when the model's complete. Makes it look a bit more sort of real world realistic. Sometimes I like to turn on the cartoon mode, which hides the boundary edges between the interfaces of the surfaces, but it leaves a nice black edge around the edge of the surfaces. You can, instead of having that on, you can just put on the shaded view, which does a similar thing, but it doesn't have the nice black edge around the boundary of the surfaces. I'll just show that one more time. But generally, you don't have either of these things turned on when you're modeling. Another thing to mention is I tried my best to make all the surfaces tangent continuous in this model, and that is evaluated using the zebra stripes tool. So tangent continuity means the boundary between two surfaces is a smooth transition. There's no there's no edge or there's no crease. It's a nice smooth transition, which is depicted by the zebra stripes, making a smooth transition. There's no wobbles or deviations. There are some parts in this model, the head back rear lights, for example. I just got a bit exhausted working on this, but these creases and wobbles are not ideal. But generally, I put in quite a bit of effort to make a nice tangent continuous model. Here's another example of slight imperfection. We don't really want this wobble going on here. But yeah, SolidWorks isn't optimized for high quality advanced surface modeling. Generally, you would use CATIA or Alias. Something like a car or a plane would be modeled in those programs, but it's good practice and fun to do this in SolidWorks, and you can get away with sort of surface modeling slightly simpler products. But yeah, this tangent continuity, it only really matters in certain manufacturing cases. Like for a car, we're going to have a glossy finish, so the way light reflects off the panels is important. I'm probably only going to 3D print this, so the way light reflects off is triumphed by the kind of roughness and surface finish of a 3D print, so it doesn't matter as much. You can also use the curvature tool, which gives some indication of curvature continuity, which is even harder to get perfect in SolidWorks. Here's an example where I didn't get it right. It's kind of going from blue to green as opposed to a smooth transition. But generally speaking, this is pretty good, and so kind of like pushing the limits of what you can achieve in SolidWorks. I did a model of a Tesla Model S many years ago, and at the time I didn't have the skills to get this nice continuity. So yeah, if this were manufactured with a glossy finish, it would look a lot better than that previous model I made. Okay, I'm actually going to remove all the appearances because it will make things easier to see as I go through the model. And apologies if I go through all of this a bit too quick, but feel free to ask me any questions below and I'll try address as best as I can. Rolling back to the start. So I started by importing some blueprint images. I just did a Google search of a Model Y refresh blueprint and yeah, cropped them and brought them into the corresponding planes. You can scale these pictures to your set dimension or dimensions of the car. And I would recommend spending some time to get them all aligned properly. So for example, making sure the top of the car in the side view aligns with the top of the car in the front view. That will just make things a lot easier. And you may have to hide certain views as you're going along. In this case, I'm going to hide the rear view. Okay, jumping forward to the front bonnet. So if I go into this boundary surface feature, generally speaking, I like to use the boundary surface. Sometimes the lofted surface or the swept surface, sorry, not the swept surface, just the lofted surface will work a little bit better. But you kind of just have to, yeah, play around with them. And the way I've approached this is I have 5 sketches, each on their own plane. So I've set up planes prior to these sketches. And I'm doing, as you can see, more or less it's like a horizontal line with a slight dip, and that captures some of the detail on the front bonnet. As you're modeling this, it's good to have various reference pictures of the car up, ideally on your second monitor. And these, I have the curvature combs turned on, which are pretty important in a lot of cases. This is one because it just shows me that all my sort of intermediate guide curves, like 2, 3, and 4, are more or less following the same curvature patterns, just with different magnitudes. And then I have two sketches, curves in the opposite direction to link that all up. Another important thing is each of these guide curves So actually just going into one of these guide curves, it's quite important. So I use style splines, which generally you want to use over regular splines. You just get a lot more control. Style splines, you draw your CVs, your control points, to draw up the spline. Now this style spline, for example, the construction line to the first CV I've set as horizontal. So essentially what that means is that when I mirror this over, because I'm just modeling one half of the car first and then mirroring it later just to ensure that the car is symmetrical. But anything that's kind of touching the sort of mirror plane of this car, you want your guide curves to be horizontal up to 1 CV, and that will ensure you get a nice tangent transition across. I could even come in and set this like second CV line as horizontal as well, and that would give me curvature continuity if I mirrored it. You don't actually want to do that in that case because it's not really curvature continuous. You would get like a bit of a flat section across, but just keep in mind that I've set these as horizontal. Also, generally with my style splines, I'm using either 3 or 5 CVs, depending on the complexity of the curve. Usually 5, and I would say that's a good rule of thumb to go by. If you're finding you need, 9 CVs to model a curve, then you need to sort of simplify your approach a little bit. Okay, and as mentioned, just highlighting some of these planes, I predefined them at specific intervals. So that gives me this front bonnet section. Okay, then modeling another section coming off the bonnet. So again, I have a series of guide curves, and I'm using the blueprints. I'm coming in here and drawing like the guide curves to match what I see on the blueprints as best as possible. Again, sometimes you need to have reference images of the actual product up on your second monitor to help out with this a little bit. Here I decided I would overextend it and then trim it back a little bit. That is also a nice way just to ensure that you have nice flow of the surface. What I mean by flow is like the sort of CV, the zebra stripes transition across the surface. Jumping forward here, what I did is I made a cylindrical sweep and saw this method from Andrew Jackson, who also puts out really good videos on this kind of stuff. Just extended them, but basically used that to trim away a gap between these two adjacent surfaces, and then modeled in another surface to link them. I probably wouldn't do this again. I would just use the actual surface fillet tool, which I did later on. But yeah, if you see that in the model and you're wondering what's going on there, that's a bit of information for you. And here I trimmed away this surface a bit more. So yeah, sometimes it's nice to overbuild the surfaces. You get a better result that way, and then trim away to get the specific edge you need. Okay, going down to this surface now. So generally speaking, I have anywhere from 2 to 5 curves in one direction. So what I mean by that is, if you're using any CAD software that uses NURBS, non-uniform rational B-spline surface modeling, you build your surfaces more or less as a square or a rectangle that can be slightly distorted. You have sets of sketches that depict the direction and they're perpendicular to each other. So here I have 4 sketches. I'm using the curvature combs just to help get a bit of insight into the curvature as well in one direction. And then another sketch and the pre-existing surface edge in the other direction. So if I go in here, yeah, this shows 4 sketches in one direction and 2 in the other. I can also set like conditions on an edge if I want it tangent to face or whatnot. I haven't done that here because there actually is an edge in the design. So yeah, again, I've just show you an image. This is an example of a reference image I would use while I'm modeling. Moving forward again, here I've done some surface extrude. So a lot of these might be hidden, but I can just right click and do show. I use these a lot because if you do a sort of planar extrude of a surface, you can then just use that surface to make a sketch, you know, build corresponding guide curves off that. I just find that's a lot quicker to do than like trying to define a plane, and you can come in and adjust these sketches relatively easy. So yeah, surface extrudes for reference planes, and then I delete them later on in the model, but a lot of these will be hidden and I just delete them at the very end. Moving on to the side panels, this was probably the trickiest part for me to get right. I would approach it slightly differently if I were to do it again. But yeah, starting off, looked like I started back here. Sometimes if you know you have, you know, obviously the side is going to connect the front and the back. If you build some of the end point, it can be easier to sort of, you know, link surfaces between them. But that, yeah, there's no one right way to do this. This is just the approach I took at the time. Here I'm building up this long sweeping surface of the kind of top of the side body. Again, I have most of these sketches hidden, but yeah, I can right click and show them. And I can also hit this hide all types to quickly toggle that on and off. But yeah, generally I'm using curvature combs on these sketches, and sometimes I'm using 3D sketches if for example, like, you know, I see this edge which most of them will be like 3D curves in 3D space. They need to follow a curvature on more than one plane. But for my intermediate guiding curves, generally you want them to be 2D sketches. It just makes it, you know, a lot easier to manage. So this, for example, is a 2D sketch, and I have, curvature combs to help me out a little bit there. Here again, I used the surface loft feature. I just found, you know, this was a case where the surface loft gave better results. So as I'm building this, I'm turning on the zebra stripes to evaluate stuff. And as you can see, that's not like 100% perfect, but it's pretty good. You can drive yourself crazy relatively easy with this stuff if you're trying to get absolute perfection. And curvature looks okay also. Sometimes I will just revert back to making planes instead of surface extrudes if they're easy and quick planes to make. Here doing another long boundary surface. So again, I'm trying to build the surfaces up, or the body up, with as minimal surface features as possible. Obviously regions where we have a, you know, specific kind of crease on the car, which again I can see we do zooming into some of my reference images. That's a good spot for a boundary of a surface. Again, doing a similar process on the bottom. So again, making a lot of surface extrudes, which if you're going through this detailed, you would want to show these because they're used to draw construction lines. Okay, now this surface was a bit of a beast. I'll show all these. Okay, so this was a tricky one because we have this crease or this sort of like protruding edge in the surface bodies, which we can also see zooming into the car image. See a little visible edge running there, but at the back and at the front, that edge goes away and it becomes a smooth transition between the surfaces again. So for example here, I want this region here to be smooth and then the edge slowly starts building up. So this is a bit of a tricky thing to do. The way I approached it was building off this kind of edge here, and then I have a guide curve here. I'll actually just go into this 3D sketch guide curve. Okay, and I have a tangent relation between this 3D curve and also an equal curvature relation between this highlighted sketch here, which is not visible at the moment. So I'm actually going to have to go out sketch 290, so there. So sketch 290, this is actually quite important what I'm doing here, so I'll go through it a bit more slowly. Okay, so what I want to do is have various guide curves along this section that I plan to build in a single surface. I know from this region, roughly from this vertice up to this vertice, I want it to be tangent continuous. So if my intermediate guide curve running from this vertice can be set so it's tangent and curvature continuous to this highlighted face, that would help a lot and kind of be necessary. So what I've done is a surface extrude off the side plane. So this is my sketch, this highlighted edge sketch here. And then I've done a surface extrude out, which intersects with this existing face. Now what I've done is I've done a sketch on this extruded surface, so you can see. And what I've used is if you go into convert entities and hit the drop down button and then do intersection curve and select your either your sketch plane or your extruded surface you're sketching on and the pre-existing surface, and then hit OK, which I won't do, but hit OK, and that builds a nice intersection sketch, which runs between those two surfaces. So now I know that if I come in and I build a 3D sketch off the same vertex endpoint, I can click one, hold control and click the other, and do tangent and equal curvature, and that will ensure now that this line is continuous with this line, which in turn means it's coming off this surface smoothly. This is quite a commonly used, I use this method quite commonly throughout the entire model. Basically, if you have a surface that you're building off another one and you want to introduce some guide curves, you can build intersection curves between either a reference surface extrude and a reference plane and make relations to that. I could also come in here and just do a style spline in a 3D sketch, hold control, select that, select the edge of the surface we're building off, and then while still holding control, select the surface itself and do tangency to face and equal curvature. But the problem with that is you don't specify the angle at which this style spline comes off the surface. Like, you can imagine there's essentially like 180 degrees that a curve can come off another surface and still satisfy the sort of tangency and curvature, because that's locked it in with the equal curvature and tangency. But if I actually delete these and move this over here and then make the same selections again, it's now saying it's achieving those relations, but it's a totally different curve. And if I manipulate round, I can see, I can see this runs off smoothly to that surface. But just doing it in 3D space like that doesn't give you control over the angle at which it comes off. So by setting it all up off a two-dimensional plane or surface, it gives that control. Hope I've explained that reasonably well. Sorry, rambled on a bit there, but it's quite important, that point. Okay, so these sketches here, I didn't need to do the same method with them because they're not actually curvature continuous. At this point, the edge is starting to build up, but I'm still using the curvature combs. And this is a good example of how the curvature combs help. I know that this guide curve is, flexing a little bit up the top, and then kind of, more, not flexing, concave a little bit at the top, and then more concave at the bottom. And more or less flat in the center, but I don't actually want it to become convex at any point. Again, getting this exact geometry or this exact form down, I'm relying heavily on images. I'm using multiple images. But obviously just going off images and blueprints, you're never going to perfectly replicate this. And then I know actually at the end of this, I do want it to become concave a little bit because it seems like it does that in the real life product. So yeah, using the curvature combs to help. Again, these are all on 2D planes. The reason this one was a 3D sketch is because it does have to, you know, I wanted it to stay more or less equidistant from here. But if you can use 2D sketches, generally that's better and more robust than 3D sketches. And finally, I have an additional sketch in the second direction in between the two surface edges, so 3. Generally, I wouldn't do that. In one direction, I might have multiple, but in the other direction, I would only have 2. In this case, I wanted 3. It just gave me a bit nicer of a result. And what I did is a style spline. This has many control vertices, 8. And then I've put in points. So I just come in and, you know, put a point on the 3D curve, and then make that point coincident with my guide sketches in the other direction, which you need to do, because if I'm using all of these guide curves to build a surface, all these guide curves need to intersect. So yeah, not sure if this is like the best way to do this, but it did work out okay. But I might try break this down, make it a bit simpler if I were to do this again. Okay, in this case, looks like I trimmed away a little bit here. Okay, I think I did that because maybe I was a bit pedantic that these zebra stripes weren't fully aligning here. So sometimes you can trim away imperfect sections like I did there, and then add them back in and get a... I don't even know if that's better. You know, earlier in this model, I was a bit more pedantic with trying to get things perfect, but then later on, just getting exhausted, stop doing stuff like that. But that is a method you can use sometimes, trimming away and then re-adding in. Which actually, yeah, brings me on just to here. So this is a pretty bad surface transition. Just gonna hide that. Yeah, we can see a big wobble in the zebra stripes here. So what I did was trimmed this bad section out and then used the surface fill tool, which gave a better result. The surface fill tool, it's kind of like a general purpose. You just specify a boundary and it fills it in nicely. And you can actually do that with a surface that isn't a distorted square or rectangle. It can have, you know, n number of sides. And internally what SolidWorks will do is build like a nice NURB surface and trim it away. So it is really useful, but sometimes you just get really wonky results. And it's like, I don't know if I'd say a gamble using it, but it's just, you don't have perfect kind of control over your surface, but it is, yeah, nice to use sometimes. And you can come in and set the relations at each contacting boundary, either curvature, tangent, or contact. And yeah, that's a nice little trick to get some better results. So you know, trimming that out and using the surface tool gave me that, as opposed to that, which is, yeah, much nicer. Okay, moving on to the back panels. Probably gonna have to start going through this a bit quicker, but yeah, more or less, like, this is the idea. I, you know, used boundary surface with several guide curves to build up my surfaces. Sometimes use the loft surface if that gave me better results. And again, just, yeah, mentioning with my style spline here, I'm setting, because this is a 3D sketch, I'm setting the first CV along the X1 axis. So it will be nice and tangent continuous when I model, you know, flip this and mirror it over the symmetry plane. And sometimes actually, if you set your guide curves up well enough, you don't need to use the constraints in the surface feature itself. Touching on this boundary surface, so it's nice to build up, you know, a large section with a single surface. But then if I come into my reference images, I can see there's like a little bit of a crease here. So what I did was build the entire section, then trim away the region where the crease will be, which I can see a little bit in the blueprints. Then just, yeah, some extrudes for reference sketches. And I made 2 boundary surfaces to fill that section. So if I come in here, I can show my reference reference sketch. I've put a little crease in, and then, yeah, made the surfaces of that to give me that little edge. So if I turn on the zebra stripes there, this is actually, yeah, the design intent. We like want to see this. But yeah, before this was done, it was just a smooth sort of transition surface. Here I've done a surface fill, a sketch. Again, I can go into this sketch and select it to see if there's any relation. So there's a tangent relation here. I have done this in the same sketch, which is, yeah, a bit easier to see. It's a bit nicer. But this is my guide curve, and if I click it, it's at the intersection of 2 faces. So those 2 faces are this pre-existing surface and the plane that we're sketching on, either a plane or an extruded surface. And then I'm setting that tangent. So that's, yeah, that's ensuring I've got a nice 2-dimensional guide that's accurate to then build this 3-dimensional surface. Again, similar here, I'm trimming away. Yeah, I found this region was a bit difficult just to get good results to, yeah, model this in accurately. What I found is if I trim away this whole section, again, because this was tricky here because I had this little crease, which actually on the product is like smooth. As you can see, there's a micro crease there. So trim away all of that, and then did a big surface fill there and a surface fill here. Probably found I had to use 2 to get nice results, and gave me that, which it's okay, but yeah, ideally you don't want these little wiggles here. I could go in and add more guide curves to fix that up if I wanted to. Again, looks like I was actually even a bit more pedantic and trimmed away more and rebuilt again. So not exactly sure why. Just gonna try remember why exactly I did that. Yeah, I mean, I was probably thinking I maybe wanted to extend. Sometimes you have to, yeah, flip the direction as well. Maybe I wanted to extend the smooth transition out, the transition point a bit further. Yeah, to be honest, I think this probably wasn't really a necessary step. But it's difficult to go back and like try to delete this now just because subsequent things are built off everything. It can be a real headache, yeah, getting the design, like managing all the errors that would introduce. So once it's done, just tend to leave it. So yeah, more or less continued the model using these approaches. In this case here, I've just trimmed away where I know the headlights will be. So just actually roll back there. Again, it's easier. You get much better results if you build surfaces that are, you know, smooth and kind of long sweeping. And if you need kind of complex boundaries, then you cut them out after. If I were to try build all these surfaces with this boundary for the headlight, I'm just not going to get good results. You can see here, if I turn on the zebra stripes, like they're smooth running up to the edges, because yeah, I've built them off a larger surface. and then cut away. So that's generally best practice. I also did that down here previously. Another useful tip, if you have a lot of the design tree open, you just want to close it quickly, you can hold Shift on your keyboard and press C. That will close it up. It's a bit more manageable. Here, yeah, just building what I'm calling the roof rail sections. More or less, yeah, boundary surfaces and lofted surfaces using various guide curves. So, won't go into detail, too much detail there. Might actually just touch on one of these. So here, yeah, I found the surface loft was giving me better results, and yeah, not sure if I have mentioned this yet, but in this case, yeah, the first guide edge built off this existing surface, I'm setting it as tangent to face. Yeah, which in the surface loft you just do the start and end constraints, which I'm also doing at the end here. You can try to do curvature to face, and you can adjust kind of the magnitude of how intense that's coming off. Generally, yeah, you want the zebra stripes turned on while you're doing this to get an idea of what you're doing. So. Okay, the front bumper. Yeah, again, very quickly going through everything. I'm just going to turn everything off. Yeah, building things up section by section at parts that make sense. So if I go back to the blueprints, yeah, I can see using the guide edges of the blueprints and also my reference images to try capture the rough form. Building it all up. Doing surface trims to cut away sections. Putting up additional surfaces. Jumping forward a bunch. Built in this section that goes in to where the light is. Here I kind of just had to take a guess of what's happening in here. Probably this is open, but again, I'm just kind of modeling this as a single large body. If I were to try go into detail of, you know, individual panels that are, you know, a certain thickness and actually mounting to the interior chassis of the car, like I'm not actually building a full car here. Like, you've got to draw the line at some point of how much detail you want to model. But then, yeah, putting in fillets, variable fillets, and fillets. Again, if I select this one, yeah, that actually wasn't a fillet. I did the previous method of using the cylinder to cut away a model between them. Generally, I think fillets are just easier to use. But sometimes, if a fillet isn't working, you can do the variable fillet. In this case, I do have different radii set. But sometimes even if you just set all the radii as the same, like 4mm, it will work while the regular fillet won't. So, useful thing to know. Then I've done a surface knit, kind of knitted everything together at this point. Sometimes it's a bit better to do more of these as you're going along, but here I got away with doing it there. And yeah, more or less at this point, this is the sort of exterior surfacing of the car done. Still have a lot of, you know, details to do, but getting to this stage was, yeah, quite a lot of work. And, you know, I can turn on the zebra stripes to evaluate everything. Overall, like, this is pretty nice. Got nice transitions in most spots. Yeah, this is what I was mentioning before. Start off with a nice transition, but then as the edge is introduced. This also isn't something you see on old cars, like, you know, from the 90s and early 2000s, because it's difficult to, you know, manufacture this as well. But modern cars kind of have this, you know, aggressive edges or like creases that are, you know, mid body panel. But yeah, it's also difficult to model in. This was another spot. I'll see if I can show that in a nice image. Yeah. If I zoom in here, you can sort of see this crease running along the side of the car, but then it becomes smooth, and you know, it's a smooth transition, and then the crease is introduced again. That is quite difficult to model, and you know, it's not actually there at the moment. If I flip the, it's sort of there a little bit actually. But yeah, basically, to summarize what I already said, when I'm making these guide curves, like the ones that are in this region will be tangent continuous to these faces, these surfaces, and then the ones sort of mid body panel where we have the crease won't be tangent continuous. I think I actually came back later and tried to make this a bit more perfect, but looking back at it now, like this is probably fine what I had. That doesn't look great there. So again, if you're going through this model, like, don't expect to be able to go through this in a few hours. Like, I would, if you're trying to use this as, you know, for educational purposes, I would say, like, in each sitting session, try to go through one of these folders and try to understand what's going on there, because there is a lot in this. And yeah, actually here, what I did was, I came away and trimmed this out and then did a surface fill to try to get slightly better results. I'm just gonna, not sure if this really did all that much. A little bit, like you can see it's like pretty smooth in the center there. And then, because, you know, over here these zebra stripes aren't aligned at all, but in the center they are. And if I go back to before I did this, yeah, you can see it's a bit of a jagged transition, so a little bit pedantic there. And doing more fillets. Going down to the roof, I don't think there's really too much to discuss there. Relatively basic. Okay, the windows have actually introduced an error into these variable fillets. Gonna see if I change that, if it fixes anything. Yeah, so unfortunately sometimes this will happen, and I'm just gonna close this model without saving it and reopen it again. So here, yeah, building up the whole window section off a single surface and then using offsets and trims to build out that border. But if I, sorry, you can see, yeah, this is offset from that slightly. Building out the side mirrors, just did a rough job with the side mirrors. in this case, the fillet's rebuilt. So yeah, that's just an unfortunate weakness in this feature design history tree. Again, yeah, doing offsets to build out some more of the details. And then, yeah, linking them up with boundary surfaces. Again, knitting that back to the main surface knit. Okay. Now to this point that I'm calling the front details, this is kind of like the lower front grille. I initially, like I did have the intention that, you know, I might 3D print this. So it obviously will need to be solid body. I can't print surfaces with 0 thickness. So I did model this all up as a surface body. But then, yeah, at some point here started adding thickness, and I just decided it would be easier if these sort of bottom sections, like the front lower grille and the back as well, if I made them as separate bodies, it would be easier for this modeling and also for 3D printing later on. So I just decided I'll make these as solids now, and then deal with the car body a bit later. And so I did that there. Yeah, and again, the rear bumper doing a similar thing. So just going over this very quickly. Again, this is a bit too complex to build in a single surface feature, so did a few various tools to try get nice transition. So actually here at the interface between this like bottom underbody, which is, you know, these parts, and the rest of the car body, I don't particularly care if it's tangent continuous, because, you know, on the actual model they're different parts. Like these are you know, aluminum metal stamped panels, and then the underbody is maybe some kind of like, you know, injection molded plastic. Doesn't really matter if they're perfectly tangent continuous, but within the part itself I do want it to be tangent continuous. So yeah, playing around. And, you know, also keep in mind when I'm doing this, I'm not coming to these kind of boundaries straight away. Like I'll make a educated guess, maybe, and, you know, use the zebra stripes, see it doesn't work out that well, try something different. I think this was like the, you know, probably it's like the 40th version I made at some point. Obviously not starting from scratch again each time, but just as I, you know, figure something out, I'll save a copy. So a lot of iteration on this. By no means am I reaching these results like on the first pass. Again, here I knew this would be like a solid body. So yeah, I can, if I hover over these, I see the outlines, but they're actually hidden. So yeah, I can do show and see that I've done these offsets. Like that. And then I'm using a trim, which is guided from a 2D sketch to cut away the regions I don't want. Here I did a ruled surface and sent all these edges backwards to intersect through the original surface. Then doing a surface trim to bring it back. So now what I've done is I've introduced all these sort of surface edges that, yeah, kind of go straight back. And now line up with this surface body. Knitting them together. here doing a surface trim of these inside sections. So if I look there and see, I've trimmed away that. So I'm making an enclosed volume, essentially, more or less. And then adding some of these surface fillets. So actually it looks like at this point I didn't solidify this quite just yet. The rear light, similar sort of thing I did up here, so not gonna go through all those details. But yeah, at this point I was getting, you know, a bit tired of working on this model for like many months in my free time. So yeah, wasn't as diligent with doing this stuff. But then at this point decided, okay, I want like these bottom sections to be solid bodies. Yeah, I want these bottom sections and the regions around the wheels to be like a separate solid body. So I just made the mental decision at this point. I'm going to make a solid body of the main car body, and then a single solid of like the front bumper and the side bumper and wheel kind of pockets into another single solid. So doing some of the thing. So here, building up these wheel pockets. Actually, I will just go back here, skipped over this. So again, so another useful thing is if I press tab on a surface, it will hide it, because that this whole body is knitted together. It will hide the whole thing. Sometimes you might, you know, press if I press shift, if I hold shift and then press tab again, it will unhide it. Sometimes you might do that over a construction extruded surface, but yeah, in which case just press tab again while you're hovering over it to hide it. Coming back to this, you know, back under bumper body, doing a surface fill on the side again to finish this enclosed volume. And then doing a knit surface here and creating a solid. So yeah, in this case this surface was still visible, but yeah, that was just used as a building tool. And as I mentioned before, I delete all these unused surface and construction surfaces at the end. Doing a similar thing with the rear lights, ruled surfaces to create an enclosed volume, followed by other surface features. Surface fill. So this is a enclosed volume made from surfaces, and then knit them together and create a solid. What I found here is that even though this surface should be a flat plane, it wasn't. So I just had to do a bit of funny stuff, like extruding off here, you know, a solid body command, and then cutting back to the symmetry plane. just to get, yeah, make it a nice flat plane. A few more small little features in here to fix some kind of like gaps in solid bodies that shouldn't be there. The main body solidify. So I'm going to hide that solid underbody. So yeah, I did a ruled surface of this, you know, bottom side, passing through the symmetry plane. Surface fill somewhere. I think that might have just been a little section that it's giving me problems coming off the ruled surface for some reason. And then trimmed them back to the symmetry plane. Delete face. Okay, this is this part here. Initially I was thinking I would make this rear light like a solid body, but then I decided, oh, maybe I actually just want to combine that into the entire kind of like main body of the car. I could have kind of gone back and, you know, changed all these previous features so I didn't build this up as a solid body, but because your design tree becomes so dependent on previous features, it can be, you know, a bit of a headache doing that. Like you delete one thing and everything breaks. So I just decided I'll use the delete face, delete all these internal faces of that solid body, and that will reconvert it to a surface body. And then from there I did a surface planar surface. So because this is a lot of edges, I would have like right clicked and did a select open loop and selected it all, and then yeah, built a surface of that. So then at this point can do a surface knit of everything, just to knit everything together, and then a surface knit of that with the planar surface I built to create a solid. I think I was having trouble doing all of that, create solid in one feature. Okay, so almost finished now. Just yeah, quickly did the side mirror bodies. Well, I think I separated them from the model because I couldn't get them to create a solid with the entire body. It's just all a bit too complex. So yeah, these were not included in the create solid, but then I created them like as, you know, solid in separate bodies, and then merged them later. Here just doing some small features on the solid bodies now, just to get everything to fit together. So if I unhide that underbody. Again, finally getting close to the end, did the wheels. I thought they would be pretty simple, but yeah, you know, I had to use some surface features to build them up. Bit of complexity in there. This is like a rough approximation of what the wheels look like. And now mirrored all these bodies over and combined them. Finally, a few small visual details like the logo badge extruded off, the side door handles extruded off, go through them. And yeah, then the last thing I did was delete all these construction surfaces. So simple way to do that is if I scroll back to before this feature, I can see all these surface bodies, they're all hidden. But yeah, go into just use the body delete and selected all those surfaces. The appearances are messing up now, but and yeah, there you have it. So yeah, there's a lot to this model. Getting, you know, a solid body of a car accurately modeled is a big task. Not sure if I'm really going to try tackle this again. Probably just going to focus on more engineering stuff, built things. But yeah, you know, it's a pretty cool model. If you like this video, if you made it all the way to the end here, thank you, and hit the like and subscribe. And yeah, if you have any inquiries for any sort of design work, reach out to me on my website, link in the description. And yeah, thank you for watching.